So I think what we're going to do today, this afternoon, is to basically we're going to do a play along game. So I'm going to drive the Connectome Explorer, and I'm going to ask you to give some suggestions for experiments that we can do. And then just for a few minutes, just to give you a taste of the different kinds of tools. And so you can enter in the chat some suggestions like, oh, test this, test that, use this tool, use that tool. But then we're going to give you about 10 minutes to just play on your own. So you'll load up Peacock and do pick a neuron that you want to investigate and ask a question. What is that? What does this neuron project to? Is this a neuron of pacemaker? Just try to use the different tools to sort of get at whatever question you want to ask about it. And then we'll reconvene. We'll answer some of your questions if you come across any sort of problems, any sort of stumbling blocks, and then we'll break out into groups to work on our Bendy assignment, where you're going to work in your group to solve an entire connectome. So we're basically trying to help you. We're modeling what we do in our classes. So this is effectively what Liz and I did with our intro courses in the spring. So with that means I need to share my screen. Okay, so hopefully you can see the main homepage here, crescentloom.com, so you all can navigate there as well. If you want to play in the sandbox, you can press the play button here. We're going to navigate over to the Connectome Explorer and launch that because we built the peacock animal in this case for our students so that they could try to dissect out the connectome. And so this is going to open up the peacock in the Connectome Explorer with the connections hidden. I actually saw a peacock on the street on my walk to work today, so I think that was fortuitous.
Excuse
also
me?
Also very strange in Portland. Somebody lost their pet peacock. Maybe it's not that strange, actually. Okay. So here we are. Let's see, I probably need to expand this window a bit, at least for my own sake. What's happening? Let me just do this. Why is it? Okay. Okay, so let me introduce to you our peacock. We can see that it has 3 muscles and basically 2 hind fins, sort of limb-like things. So you see that these 2 muscles, the anterior muscles, are contracting simultaneously. Whoa. And then this one that connects the 2 limbs contracts to pull them together. So one thing that we could do is figure out which motor neurons connect to which muscle. So these kind of look like muscles. They're just drawn at, they're neurons that project to those muscles. We don't actually see the muscles here in the simulation. This is just in the brain, but we can record from these muscles. So I guess I'll do that to start. I will note that some neurons won't show action potentials. I think that's in the works. Most do. Most of them, as long as they have an axon in the model, you'll see action potentials. So in this case, these cells are spiking, but the resistance between its axon that's not drawn and the cell body is high, so we don't see the spikes. Okay, so I just clicked on the select button so that I could record from this one muscle, or motor neuron, I should say. And so does anyone have any ideas about how how to identify which motor neurons are projecting to which muscle.
I'm watching the chat, by the way, so if people want to type stuff, I can read it aloud.
Thank you.
So I see look for correlations in activity. I'm seeing lots of suggestions. Excite Kia and measure from other motor neurons. I'm seeing selectively inhibit or excite, stimulate, excite a motor neuron. Those are all the suggestions that have come in so far.
Cool. So the correlation part, I guess, is a little bit visual, right? You have to sort of watch the two things at the same time. With only 3 muscles, that's pretty straightforward. One thing I should point out is that you can change the simulation speed, and we can slow that down, which if you're having a hard time sort of following the correlations in this sort of qualitative visual way, slowing it down can help. So I think we see that this cell is depolarizing as the 2 muscles are, or as the 2 limbs are coming together, suggesting that this posterior middle muscle may be the one that's being driven by this motor neuron.
Stimulate it. Let's see.
So let's stimulate it and see.
Yeah,
So,
stimulate Kia was
so
a suggestion.
Click on the stimulator and stimulate.
Yeah, it looks like it.
Yeah, so that muscle there that's pulling the 2 limbs together is just permanently contracted now, right?
Ali suggested that we excite Kia and measure from other motor neurons.
Okay.
To see if there's any, I guess, like motor neuron to motor neuron.
Sure. So let's see, we're recording from all 3 of the motor neurons now, Kia, Gu, and Nil. Good names. And stimulate. So it looks like those 2 motor neurons continue their pattern unaffected. Another thing we can point out is that this can expand. If you want to zoom in on the recordings a little bit. So again, you can see the other 2 motor neurons are not affected by that.
Eric, there's a question in the chat. Could you highlight again the difference between motor neurons and muscles in this simulation? So which are them? Yeah.
So exactly. So this diamond here is this hexagon is the brain. So everything, central nervous system, let's call it. So anything within here is a neuron. So this red diamond is a motor neuron that projects to the muscle. The muscle is not shown here. The muscle is only shown on the creature. And you can tell when a muscle is activated because it lights up, it goes kind of white and flashing. You can't record at this point, you can't record the electrical activity of muscles. That's not built into the game currently.